Hello, and welcome to Backer Breaks It Down. In this lesson, we're going to look at applying coordinates. We're going to find perimeter and area in the coordinate plane. We're going to use transformations to do so. So, since we're going to be finding perimeter, we will most likely need to use our distance formula to find the length of a side. Remember, perimeter is where you add up all the sides of the figure. Now, there are some perimeter shortcuts. For instance, if we're trying to find the perimeter of a square or a rhombus, we can simply find one of the sides and multiply it by 4. For a rectangle, we can find 2 times the length plus 2 times the width. And then, of course, we have our area formulas, and that kind of gives us a general idea of what we need in order to find the area of a square, rectangle, triangle, or even a trapezoid on the coordinate plane. So we can use transformations because if a rigid motion, and that would be like a translation, a rotation, a reflection, if you perform it on a figure, the preimage and the image are congruent, which means that like the perimeter and the area of the preimage and the image are equal. So in this example, we're going to translate the rectangle so that one vertex of the image is located at the origin. Because if you think about it, that's going to make this distance formula so much easier to use. Because if one of your points is the origin, let's say x1, y1 is the origin, then this right here is 0, and so is this. So you're going like a number minus 0. Okay, so we're going to take our rectangle and we're going to move it so that one of the vertices is at the origin. And as you can see, let me see if, okay. As I'm moving it around, the perimeter is not changing, the area is not changing. The only thing that's changing is the location of the rectangle. So I'm going to move this so that one of my vertices is at the origin. So maybe I'll put y at the origin. See? And so I want to find the perimeter and the area of this rectangle, which means I need to know the length and width of the rectangle. So I need to find, like, maybe I call QW the width. Oops, sorry about that. And I'm going to use my distance formula to find that. But it's going to be so much easier because y has the coordinates of 0, 0. I can say the same thing about my other dimension, BO. It's going to be a lot easier for me to find because of that translation. So I already did it. Wow, see, that was fast. And I determined that BY has a length that is equal to the square root of 208, and that QY has a length equal to the square root of 52. So then I can just substitute these into my perimeter and area formulas to calculate the perimeter of my rectangle, the area of my rectangle. Now I'm using the actual square roots in my calculations, but you can always find decimal approximations first and then calculate the perimeter and areas. But if your calculator has a square root button, I would use that for sure. Make sure that you exit the square root before you go typing in anything beyond that, though. As you can see, the perimeter is approximately 43.27 units, and the area is exactly 104 square units. And so there you have it. Using transformations to find perimeter and area on the coordinate plane. Simply translate the preimage so that one of the vertices is located at the origin, and it makes finding your dimensions so much easier. And that's how Backer breaks it down.